Hello everyone, today we're going to solve the third paper of data science. Our first question is discuss attribute by attribute problems that may have found into the following database. And this is our database. Our attributes are customer ID, zip, gender, income, marital status, transaction amount. In customer ID there seems no error. In zip, in our customer ID 1002, the zip code is J2S7K7. That doesn't seem right, as there are alphabets in a zip code, so this can be an error. But actually, mm, this is actually a postal zip code of Canada. So the user who entered this may be a Canadian. So there may be a chance that this is not actually incorrect. And our other anomaly is this 6269, as all the zip code is of 5 digits, but this is of 4 digits. So this seems incorrect, but maybe there is a leading zero, or this is actually a zip code of some other country. So yeah, these are the problems of zip attribute. Now the gender. There's only one problem, that there's a missing of value in customer ID 1003. There is no gender specified, so this is actually missing of value. Now the next attribute is income, and there's this negative income, as income can't be negative, so this seems to be a error. uh, Maybe there are some reason, or maybe this negative sign is assigned by the database manager and it signifies something, but here we don't know what actually happened. And the other thing is this value 1003. uh, this is very large value. This can create problems in our data set. And the last value, as all are rounding off of 10, but this last value is 9999. So maybe this is a value assigned by the database manager, that this value represents something missing of value, or for some reason some other at some other problem. So these are the issues with income attribute. Now the marital status. Here there are two S's and we don't know what this signifies. So maybe S can be for single, uh, or maybe S signifies separated. So we don't know that. And the last is transaction amount, and this seems correct. So that was our first question. Now let's see our next question. Our next question is apply data wrangling process in following database. So first we have to uniform the data. Uh, like as Jagdish is the name and Singh is the surname, we have to apply this for all the entries of name attribute. Here Gupta Vinod, we just have to switch it with Vinod Gupta. Vinod Gupta. Same goes for Tilak Jain. We have to switch the places of surname and name. Now the next is phone number. Uh, Sorry. Here the first three digit seems to be the postal code or area code, like 731. So we have to specify every uh, first digits for, like, we have to separate the actual number with the area codes. Now the next is birth date. Here the dates are of different formats, and we have to achieve uniformity, we have to use the same pattern. Let's say I want to use this pattern for all the dates. Sorry. So what I'll do is I'll calculate August month, and I will uh, change every dates with this pattern. Here year is not specified, so we have to uh, omit this entry for data wrangling. The next is state. Here state abbreviations are not completed, like for TN it may be Tamil Nadu, so we have to uh, use the full form of that. And other than that, everything seems fine. So the only entry which will be omitted will be the Jackie Agarwal, and that was our second question. Now let's move to our next question. Question 3. Consider the following database. Apply any 3 methods for finding out missing values. Our first method is with user defined constant. So for that we can assign any constant that signifies that this value is missing. Let's say for this I'll assign here 0, and for this I'll assign here a categorical value of empty. This was our answer for first question. For with mean and mode, for mean and mode I have to calculate the mean, like 350 plus 302 plus 400 plus 89 for arithmetic values, and I have to calculate the mean of it, and that will be the answer here. And for mod, the value which is repeating the most will be the mod. For here it will be Ujjain. Now for with random draws from the distribution of the variables, I have to assign a random value. Let's say here I'll assign 450, and here I'll assign Jaipur. So this was our answer for question 3. Now let's move to our next question. Our next question is compare the attribute for classification of bank loan by assigning applications to one of the 3 risk classes using gain index and information gain approach. So this is our answer. First we have to calculate it without splitting the attributes. So the overall information gain, according to this, we have 3 classes A, B, C for risk class, and the overall information gain without splitting is 1.57. Now we have to split it according to attributes. Our first attribute is owns home, married, gender, employed, and credit rating. So we have to calculate the information for all of these attributes like this. These are the weighted information. So for home it's 1.52, for married it's 0.846, for gender it's 0.69, for employed it's 1.12, and for credit rating it's 1.52. Now we have to calculate the information gain, which is information before split when subtracted from information after split, and our information gain and our highest information gain will be our root node. Once we identify our root node, we have to again create the table, but this time without the attribute of our root node. Here our root node is divided into 2 classes, male and female, and male is terminating with class B. So we'll just uh, remove all the class B risk class, and then again create the table. And after that we'll again calculate the information before split for this risk class, and again we'll divide these into different attributes, split these attributes, and individually we'll calculate their information. In this, the married the attribute will have total information of 0, and as it has the lowest information, its information gain will be the highest, and hence our next attribute will be married in the decision tree. So this is how our decision tree will look like. Now the next approach is Gini index approach, and our formula for Gini index was 1 minus sigma pi square. We have to again calculate the Gini index before split for the risk class like this, and our Gini index will be 0.66. Then we have to split the attributes for home, married, gender, employed, credit rating, and we have to individually calculate their Gini index and weighted Gini index. So for home, our Gini index will be 0.64. For married, our Gini index will be 0.40. For gender, our Gini index will be 0.358, and for employed, our Gini index will be 0.475, and for credit rating, our Gini index will be 0.64. Now we'll again calculate the gain, which is Gini index before split subtracted by Gini index after split, and our maximum gain will be our root node. Here gender will be our root node, and then again we have to create the same table without the gender attribute, and we'll get the same decision tree. Thank you for watching. This was our paper.